Hello, it's week number 2 for us, and we have new assignments for this week. And look, this looks like a list of assignments. It's all focused on piecewise functions. Okay, it's Tuesday, and look how many of you already finished your assignments. So when we meet on Wednesday, I hope to have a really nice conversation. Evaluate piecewise functions. Here's a piecewise function. This whole complicated looking set of numbers. But if you think about the word piecewise, you know that piecewise is kind of in pieces. So when you think about it, we have a function that's all chopped up in pieces. And this one happens to have 3 pieces, 1, 2, and 3. So what we need to do, we need to evaluate. When x is 1, I can completely ignore first and second part of the function. All I have to focus on this function. That's how a function looks like when x is 1. So all I have to say, well, when g of 1, if that's the case, here's how I'm going to evaluate. I'm simply going to substitute 1 for each x, and ta-da! I'm done. I just evaluated piecewise function. Second example. This one looks a little bit different. So let me focus on domain. This domain, first part, it says this function is only looking like this when x is between negative infinity and negative 7. Then second piece of this function is between in an interval between negative 7 and 2, and it looks like this. And then function, again, this next piece of function is in interval between 2 and positive infinity, and in that case, function completely looks differently. Okay, here I am. I'm just going to quickly show. So I'm looking on first interval, this one, from negative infinity to negative 7. In this interval, this is how a function is going to look like. Okay? Then we have a second interval. Second interval is this. Function is going to look like this. So this interval is from negative 7 to 2. So function is going to change the look completely. And then how about this one? The last piece of function in this interval between 2 and infinity, it again changes its looks. So when you go to Desmos, graph all 3 functions and then kind of focus, can you combine these 3, chop them up, and make your own function, okay? But this is not what the lesson is all about. I just wanted to show you how it looks like because I like to see models and pictures. So we're going to erase this and we're going to just focus on what we need to do, which is evaluate. Okay, so let's evaluate. We need to evaluate when we need to evaluate g of x, which is g of 7. So we need to focus on which interval, first, second, or third interval. G of 7. 7, yeah, it's not in here, it's right here. I like it, right here. Okay, so that's what we need to use. Well, I guess this is what we're going to do. We're going to use that function, substitute this 7 in, and we are good to go. 8 times, what is it? 7 minus 5 is 2, so my value is 16. We're done. That's it. All right, let's evaluate step functions. Well, step functions are just type of piecewise functions. Look, it still has pieces, piece number 1, 2, and 3. And I call this piece number 1 because we're just like anytime we read left to right. So as I move left to right, part number 1, 2, and 3, it kind of flows. And you can tell that these are really in pieces. First part starts in interval negative 9. It includes negative 9 and then stops in interval at 0x, but it does not include 0. And then it jumps up to when x is 0, jumps up here, moves all the way to 3, and includes 3 as well. And as soon as it gets over 3, falls down. So 3 point something something is right down here in these 3 pieces. So what we need to do is we need to match each expression with its value. Sure, so we're evaluating. We have 4 points to evaluate. We're going to evaluate a couple of them, and then we're good to go. Like we did in prior one, we're looking for evaluation of f of -9. So -9 is our x. Here's -9 up here. Let's scroll down. Well, mine y is -7. Okay, I guess my answer is -7. That easy. What is the value of function when f of x is -0.0001? Okay, let's find it on a graph. I'm looking for x. -0. So it's just close to 0 on the left-hand side because it's negative. So if I scroll all the way down, oh, I guess it's still -7. Okay, it's still -7. Ta-da! What's the value of f of x? Meaning, what is the value of a function when x is 0? Fine, I'll find x is 0. And value of function, I hit it right there. Value of the function is -3. Or my y, or f of 0 is -3. Ta-da! The last one is f of 0.001. So it has to be 0 point. It's positive 0, believe it or not. So it's on just slightly over 0. So I guess it still hits right here in this domain. So it's still answer right here. And we are done. Okay, let's look at another part, really. Oh, here's piecewise function graphs. Here's my function. G of x is 5 minus x in an interval between -2 and +2. But the same function is actually looks like 3x minus 10 when x is between 2 and -4. But be careful with it greater than, less than, or equal to. So what is the graph of G? So let's focus on intervals. It says a -2 in the interval, first interval, -2 to 2. It has to look like this. 5 and then -x. So what I'm looking for is how to graph this. Well, let me just pretend right here. Let me put it on the side. That's a -5 plus -x plus 5. This is my slope. This is my y-intercept. Y-intercept of 5. Slope is -1. So it has to be the A. So it has to be, let me see. This one is crossing at 5. So is this one. So according to the first piece of the function, it could be A or B. Let me look at the second piece of the function. Second piece of the function says in interval 2 to 4. Okay, but guess what? This is 3x minus 10. So that kind of looks like 3x minus 10, meaning 10 is -10 is y-intercept and 3 is a slope. Okay, I can't see the y-intercept, but I can see slope in both of them. 1, 2, 3 up and 1 over. 1, 2, 3 up and 1 over. They're both showing same. So the trick is it's all about the sign equal, less than, and equal to. This is what I need to pay attention to. So let's refresh our memory. When we use less than or equal to or greater than or equal to, when we're drawing it, this means it includes the point on a graph. But when we use less than or greater than, we're not including the point, so our picture on a graph is empty circle. That's our key for today. We need to pay attention to these signs right here. Looking at the first interval, it has both less than or equal to signs. So I'm looking at a graph. This one has a proper symbol and this one has a proper, should I say dot, while this one does not. this is not our answer. It has to be A. Let's try another example. So let's focus on first interval. First interval says x is between -4 and 0. Between -4 and 0, right there. Okay, and the first part, it says it's equal to, this is exactly 0. I like it because this is an equal to, this is less than 0. It does not include 0. That's what I should say. So first one is accurate, but so is the second one. So first one, it's not helping, but let's look at the second one. Second interval is, let's do this color. It's between 0 and 6, and they are really strict. It includes 0 point and includes 6 points. Includes 0 point and include 6 point. Include 0 here, includes 6, include 0, include 6. It's not that one either. So what do we need to look for? The only last thing that I have to check is slope. So in this interval, function is -4. Its function is -4 here and here. So this has to be giveaway. So my function is 3x plus 4, meaning this is my intercept, and this is not showing correct intercept. Here's correct intercept. So it has to be this answer. Yes, we figured it out.